Alrighty, welcome to the last video of Chapter 4. We wrapped this one up pretty quickly. Note that we are skipping section 4-6 because it requires graphing calculators, so we're moving right on to 4-7. This is inverse linear function. So if you have a function, that means an input maps into an output based on some kind of pattern or relationship. What does it mean to take the inverse? So an inverse relation is what you get, the set of ordered pairs that you get when you switch what's the input and what's the output. Okay, so if you just take a coordinate x comma y, maybe it's the point 3 comma negative 5, right? Then the inverse is just swapping y comma x. So the inverse would be negative 5 comma 3. So it takes the input and makes it the output, and takes the output and makes the input. So it's basically a way to undo whatever you just did, because you're if you plug in a 3 to the original function and you get out a 5, then you take that output of a negative 5 and you plug it into the inverse, you get back a 3, whatever you had. So I'll give you some examples in a second, but you'll see right away that they basically undo each other. So that's an inverse relation, is swapping the x and y's for ordered pairs. So an inverse function is swapping the x and y's for an actual equation. That's how you find it. So the inverse function written f inverse of x, okay? F inverse of x is called f inverse, or the inverse of f. So f, and then it's like an exponent negative 1 of x, but it's really not. It's pronounced f inverse. This is well, it's hard to define, so it seems like I didn't even finish the definition here. But what I would say is the inverse of a function written as f inverse x and pronounced f inverse, or the inverse of f, is the function with input and output exchanged or swapped. Okay, so let's look at some problem-solving tips and maybe some examples and make sense of this. Problem-solving tips. To find an inverse relation, you just exchange the x and y coordinates. That's what I just said. But to find an inverse function now, see here I put important steps. This is really, really important. You want to write this down, put a box around it, put stars by it, something like that. So step 1, change the f of x into a y. This is simply because when you're rearranging and doing math on the equation, moving a y around is a lot easier than moving an f of x around. Technically you don't have to do this step, but it's quite beneficial later on. Step 2, exchange the x and y variables. So wherever you have an x, change it into a y. Wherever you have a y, change it into an x. So instead of having an equation y equals something, you're now going to have an equation x equals something. Third step, this is the step where you're actually doing a lot of math. You solve your new equation for y. So after switching x and y, you now have y mixed up over in the middle of the right-hand side where the x used to be. So you have to rearrange and solve for y. And then lastly, because you're finding the inverse now, we change the y back into, instead of changing it into f of x, we change it into f inverse of x. So let's see what this looks like. A couple more problem-solving tips. The inverse function will undo whatever the original function does. So some examples: multiplication and division are inverses. So if something is multiplied by 5, the inverse would be divide by 5. Also square and square root are inverse of each other. So you do one thing and then you do the other, and it undoes. Okay, so if you make a graph of something visually, the inverse function will appear to be a reflection over the line y equals x, and we're going to see that immediately in the next graph. So let's see what it looks like on a graph. So we give it the relation 2, 4, 3, negative 5, and 0, 3. Then we're going to find the inverse. So the inverse of the first point, you swap x and y, will be the point 4, 2. The inverse of the next point, you swap these, you'll get negative 5, 3. And you swap the last one, and you get 3, 0. So let's plot the inverse, and then let's plot the original relation, and see how they compare on a graph. So 4, 2 is over 1, 2, 3, 4, up 2. There's 1 point. The negative 5, 3 is 1, 2, 3, 4, 5, 1, 2, 3. And lastly, 3, 0 is 1, 2, 3, 0. So those are the 3 points in the inverse. And now let me change to green to plot the original 3 points. 2, 4 is over 2, up 4. There's 1. 3 negative 5 is over 3 down 1, 2, 3, 4, 5. And lastly, 0, 3 is right here. So you can see actually that this one here, the inverse, looks like it's reflected over this line. This one here looks like it's reflected over this line. And lastly, this one here, again, looks like it's reflected. So when you switch anything that's on the x-axis with the y-axis, they go from over here to over here, which is a reflection across this diagonal line. So that's how you can visually see if you've done it correctly. If you plot the original and you plot the inverse, you can visually see that they have reflected over this diagonal line. And this line right here, of course, is y equals x, because the slope is 1 and the intercept is 0. Alright, let's do a couple of practice problems where we're actually solving for the inverse, and then we'll be done with this chapter. So, step 1, change f of x into y. So y equals... Whoa, that was weird. My computer just glitched out. Y equals 3x minus 5. That was step 1. Step 2 is to switch the x and the y. So now we write x equals 3y minus 5. Now we solve for y. So here's where we have to do math. So first we're going to add 5. Notice that's the opposite of subtract 5. So now we have x plus 5 equals 3y. Now we divide by 3, divide by 3. So I have y equals x plus 5 divided by 3. And the last step is to change y into f inverse of x equals x plus 5 over 3. So this is the inverse function of this one. Now think about what that really means. If you take a number and you multiply it by 3 and then you subtract 5, that's the exact opposite as if you added 5 and then divided by 3. These steps will exactly undo whatever you did up here. Okay, let's do one more example. First thing, change f of x into y equals, so here we have negative 1/4 x plus 12. Okay, swap x and y, so x equals negative 1/4 y plus 12. So now do the opposites. Remember that when you're solving an equation, your golden rule here is to go in the opposite order. So we subtract 12 minus 12, cancel. X minus 12 equals negative 1/4 y. Now we're going to multiply both sides by negative 4 because that's the opposite of 1/4, so that cancels. And here we've got a negative 4. Make sure you put parentheses here, that's really, really important. So finally we have y equals negative 4 parentheses x minus 12. Okay, change the y into f inverse of x equals negative 4 parentheses x minus 12. Now, again, comparing the original equation, if you first multiply by negative 1/4 and then you add 12, to undo that you need to subtract 12 first and then multiply by negative 4. So the inverse function is a way to undo whatever the original function was. So congratulations on finishing chapter 4, all about linear equations, and we'll go over all this stuff in class.